Welcome to this sampling and testing webinar called the SHACP or Sample Handling Control Points. And this webinar is sponsored by two parties, both at one end of the sample pipeline. We have QualiTru sampling systems for aseptic sampling technology, and we have bioMérieux, which is your micro diagnostics partner. So why this webinar and how did I get involved in talking about sampling and testing? Well, the other day I got a call from the doctors and I was asked to come in for my annual blood test. And you know, I really do not like the needles. I really shiver. So to distract myself from the nurse's activity, I looked out of the window and started to thinking about sampling and testing in the clinical industry. You know, what happens to a blood sample, where does it go, and how does that process work? So after my visit, I went home and looked into some literature around the clinical diagnostics, sampling and testing. And to my surprise and horror, I found an article that stated for the clinical laboratory, errors that occur in the pre-analytical phase, so this is before the testing, may account for up to 75% of the total laboratory errors. Well, first of all, I wasn't very happy to see that there are errors being made in my blood analysis, but also what really struck me was that the majority of these errors were prior to testing. So this author reckoned about 3/4 of the errors were caused by poor sampling taking techniques and poor sample handling. And I started to think about the dairy industry because I've worked a long time in this industry, and I started to think, maybe in our dairy industry it's similar, and actual sampling and handling of the sample may also be what I call the weakest link in the supply chain for sample and testing. Because we do test a lot in our industry. We test from the cow to the shed to the vet, and then of course we test the tanker. Then at the factory we triple our testing because essentially we start testing in process, we start testing raw materials, we test the environment, and of course we test the final product before it leaves the factory and goes to the supermarket and our customers. And so why do we sample and test in the dairy industry? Why do we do so much testing? Well, I think it's really important to understand the role of sampling and testing in what I call the food safety and quality control pyramid, because at the bottom of this pyramid, we have the activities that we do in the factory that produce good, safe products. So we have our manufacturing controls, our quality controls, and of course our food safety controls, all being done by operators in the plant. And then above this control level sits the verification. So we sample and test to actually verify that our controls in the factory are working. So we can do, as I said before, a lot of sampling and testing for verification. And at the top of the pyramid is where we decide what to do with these verification results. And it drives continuous improvement because based on the verification results, we can then improve our controls at the bottom of the pyramid. And I have been lucky to sit at the top of the pyramid for some time. So the power of the result became very, very clear to me in the latter part of my career. You see, if a result is in spec, then I'm a happy man. I have no problem. And basically the product is all good to go. However, if the result is out of spec, things happen. I need to make a decision at the top of the pyramid what to do with the product and what next steps to take. So it's fair to say that I'm less happy when a result is out of spec. And Remarkably, in our industry, we do a lot of reporting by exception, so which means that I rarely see the good results and mainly always deal with the bad, so it doesn't improve my mood. But one of the first things that I've come across when a result is out of specification is the immediate attitude that, wait a minute, that must be the sample. There must be something wrong with the sample. Let's have another retest, which of course is possible perhaps if you have a quality problem. But if it is a food safety result that is out of spec, then unfortunately you cannot rely on a retest result to clear the batch. So an unexpected result, and certainly has done this to me, will highlight the importance of the sampling and testing process. Now, I started my career in the New Zealand dairy industry about 30 years ago. And my first job was an operator in a butter factory. So I was a butter maker, and as part of the role that I had, I took samples. And surprisingly, perhaps, but as an operator, I was not really aware why these samples were taken. Nobody actually told me that this is the reason why we take this sample. We actually had a list, and part of your job was to just take the samples on the list. I didn't get a lot of training, so when I was trained, I walked around with a senior operator, and essentially this man was telling me that this is where you stick the needle for the sample, and this is where the sample goes, and this is what you put on it. There was never really a formal sampling procedure, and it was sort of assumed that operator was a sample technician. Then, of course, as an operator, you always have a priority, and our priority was always to keep the process going and keep the damage or waste to a minimum. So when I, with my samples, come into the control room and there's an alarm going off, then very more often than not, the samples sort of get put on the desk, and we deal with the issue at hand. And only a few hours later, we realize, oh, these samples, they should go into the sample fridge. So that was my experience taking samples. After that, I got some experience in testing samples. So I actually ended up in the laboratory, and I really like this picture because this is the sort of laboratory that I was trained in, and they look quite different now. But anyway, as a laboratory person, I actually realized that the sample we get is the sample we test. So we do check the sample for temperature, we do check the sample for condition. However, we don't know anything about the history of that sample. We just take it as a genuine sample and we test it. And this all became very clear when the laboratory I was working for was going through the accreditation towards ISO 17025. And suddenly the handling of samples and what controls that we needed to implement for these samples became very, very clear. So that's really my background. So I started taking samples at the start of my career. I ended up testing samples later on, and at the latter part of my career, I made decisions about results. And so when I looked at my experience, there were certain areas that I felt we can improve on. So I developed something called the SHACP, or a tool that I think would add value to your business in sample handling. And yes, SHACP stands for sampling. It's a combination of sampling and HACCP. So you see, when we look holistically at the sampling and testing, we can talk, and I talk about the diagnostics chain. And it's not that dissimilar to your blood sample taking. First, we start with a sampling plan. And in my case, that is the doctor that is setting the sampling plan. And then, of course, the nurse takes the samples, and then they get put in a dedicated sample fridge to go on a dedicated sample courier to go to the laboratory for testing. And then the results come back to my doctor. And this is Seems pretty straightforward, but when you look at the dairy industry, the big question here is who does what. So first there's the sampling plan, and this could be quality assurance, it could be the manufacturing team that set the sampling plan. And then the samples are taken, as I said, by the operators and transferred by someone to the laboratory where samples are tested by a laboratory, whether that is, it can be internal or external. So before the results come out and go back to the manufacturing manager or the quality assurance person. So the big issue here is that it's often not that easy to that there's various different parties involved in this diagnostics chain, and that does not make communication very easy. Let's first talk a bit about the sampling plan, because one of the things that I come across when I visit factories is that when I ask the question, so why do you sample this and why do you take this sample? One of the answers tends to be, well, because we've always done this sample. And I think it's important, and I'm not going to dive into this too much because that's a separate topic, but you need to ask yourself some really good questions like, hey, why do we do this? And it's a fluid journey. It's not fixed in time. You can change your sampling plan based on what you find. Essentially, you always need to sample and test with the end in mind. You need to really ask yourself the question, what does this result tell me, and what is the impact of this result if it is not what I expect? And talking about the result, I mean, I work in a team within bioMérieux, which is called Augmented Diagnostics, and I really find that quite exciting because I deal with a lot of experts in data science and microbiology. Now, this schedule sort of shows what should happen when we get samples. Basically, you get your samples and you spend money testing those samples, and out of those tests come the results and data. And unfortunately, in a large number of cases, if the data are within specification, they get sort of put away in the cloud, never to be looked at again. Only if the result is out of spec do we get a reaction. But I think we can do so much more. So when you take results and data and you put it into what I call an augmentation process, an enhancement process, you may actually get some insights. And this could be links or connections or correlation between different data sets within your business. And based on these insights, you can then actually optimize your verification design, or as we call it, sampling plan. And so then essentially you have some form of prevention or predictive diagnostics. Of course, it all starts with a sample, and the sample integrity ensures valid results, and that of course then drives continuous improvement. So let's look at the sampling and process, the sampling, taking samples and putting these samples on a courier towards the laboratory. If we highlight the taking the sample and the sample transfer parts of our diagnostics chain, we have something like this. So we start with sample materials, we need to label the sample, take the sample, then we store it somewhere, we transfer it some way, and it ends up at the sample reception of our laboratory. Now, this is just one example of the sampling process because of course, some people do subsampling, and then we have a few more steps in this process flow diagram. Now, the good thing of having a process flow diagram is that we can start using HACCP thinking. You see, if you have a process, you can actually, at each step of this process, ask yourself the question, what could possibly go wrong? Or how can we control this? So essentially, what could possibly go wrong, or what are the hazards? We identify those, and then we have a tool to start talking about how we can improve the controls around this. And that then essentially is what the SHACP is all about, to prevent us like this donkey hanging in the air. Because if I go back to my experience and if I dive into 30 years back, what could possibly go wrong? Here are some suggestions. With regards to the materials, we could have the wrong sample container, the wrong tools, and then, of course, with the labels, often I've seen very many smudged labels on samples because pens don't write well when it's wet. Clearly, when we take samples, we have a big step where we have perhaps a poor procedure or a bad procedure or no procedure at all. We can take samples at the wrong time if we don't specify this clearly. And if it's not clear that the sample needs to be aseptic, then we can get some real problems with contamination. Storage is good. Who owns the sample storage fridge in your control room? I mean, who looks after that? And one of the things with ISO 17025 is that the laboratory took over the management of that particular fridge. How do we ship samples from our factory, our plant to the laboratory? One interesting event happened a few years back in my part of the world, where the South Island of New Zealand is divided by a few rivers, and one of these rivers flooded, and it was impassable for a couple of days. And essentially, the southern half of the island was cut off of the northern half, and the factories in the south needed to get their samples to the laboratory in the north. So that was quite an interruption that you do not predict, really. And then finally, the sample lands in the laboratory, and one of the things that can go wrong is that you do not have clear criteria for acceptance. So essentially, if after 48 hours those samples finally land in the laboratory might just test them because they are at the right temperature. If you dive deeper into taking the sample, the way that the SHACP would work and your HACCP thinking works is that you ask the question, what can go wrong? And essentially, aseptic sampling is tricky, and clearly what can go wrong is that you contaminate your sample, and that can then lead to absolutely invalid results because we find bugs in the sample that are not in the process. So the control really is to have a good look at your sampling equipment and use a fit for purpose aseptic septum like the one shown in the picture. How can we control? So now we've seen what can go wrong, and the list is definitely larger than the one I've shown you. A very good way of controlling materials and labeling is pre-issue. Laboratory issues the samples and the labels, and essentially operators only have to take the samples and put them in the right sample container. Taking the samples, I cannot stress enough, is that we really want to ask the question, why? Why are we doing this? Why do operators take this sample? Because it makes procedures and training so much more easy. If people know why, they will follow procedures. If they don't know why, they will find a smarter way, well, in their mind, a smarter way to solve the problem. Storage and transfer, I cannot, it's basically with dedicated equipment or dedicated couriers. And of course, sample reception, you agree on some preset acceptance criteria like time, and you basically make sure that the laboratory does not test your sample if it's outside a delivery time frame. So let's summarize. A robust verification process provides you very valuable feedback on our food safety and quality controls and improves our decisions. It sits between the factory controls and our management response in the pyramid. And you do spend a lot of money. We do spend a lot of money on verification, so we should make use of that. Now, the SHACP tool that I introduced today is clearly a simple way to review all the steps in your sampling to testing process and see and identify the areas where you can improve the controls in that process. So you map the process from sample to test, and then you ask yourself the question, what can go wrong, before you find a way of controlling or reducing the risk of that hazard. And then finally, you implement those controls to have a more robust sampling to testing cycle. But remember the impact. We need to test with the end in mind, and that means that you need to instruct your laboratory really carefully and tell them that if in doubt, throw it out. Thank you for your attention to this webinar, and I hope that this has clarified some of the potential weaknesses in your sampling and testing protocols. Thank you.